Hello everyone. So today's topic is typical ResNet architecture, and this is an introduction to ResNet architecture. So ResNet stands for Residual Neural Network. So it was introduced by Microsoft Research in 2015, and ResNet is known for its ability to train very deep neural network effectively. So as of I have explained in the previous videos about neural networks, so you can go through that. And coming to motivation for residual learning is traditional deep learning neural networks suffer from the vanishing gradient problems, and residual learning aims to address this issue by using shortcut connection, and these shortcut connections allow the network to learn functions. So also have also made a video about this vanishing gradient problems, and I'll be explaining once again. So basically, vanishing gradient problems is nothing but while back propagating, I mean, like this is the output you need, and so based on the output you have to adjust the weights. So while you are adjusting the weights, when one of the weights, some of the weights will, the values of the weights will become so low that it considers as it's not there anymore. So if this happens, so the nodes that are previously that have been initialized would gone missing, and in the future it may cause some problems. So this is what the gradient vanishing gradient problem means. So this ResNet will overcomes that by address the issue by shortcut connection. Shortcut connection is nothing but instead of connecting to every single node from input layer to hidden nodes and hidden layer to output node, so it will choose a path which is short, and basically from hidden node layers means there won't be just one layer like this, it will be multiple. So there will be n number of like around 100 of these nodes, or 200, it depends on how what kind of model you're training. So those many hidden layers will be. Among these, it will take a shortest path and it will take that. So that at that time you don't have to worry about the gradient values that may vanish. So coming to building blocks of ResNet, the basic building block of ResNet is the residual block. So a residual block consists of two convolution layers with a shortcut connection, and the output of the shortcut connection is added to the output of the second convolution layer. So this one convolution layer and this one convolution layer, and as of you know, basically convolution is applied for images and video, audio. So this kind of things have been trained, and shortcut is nothing but see, as residual consists of two convolution layers with a shortcut connection. So there will be a layer which usually it will go through this also, but there will also exist a shortcut path, so it doesn't have to go through all this. And if a gradient vanishing problem occurs, so it can use this path. So there will be two paths basically. So when the actual path is not satisfied, it uses the shortcut. So coming to stacking residual blocks, ResNet architecture typically stack multiple residual blocks, and deeper ResNet models have hundreds of layers. And stacking residual blocks allows the network to learn complex features. So stacking multiple residual blocks. So as you have seen, right, this is one of a layer, and it is been stacked upon this multiple layer. It's nothing but which will make it more perfection, and it will bring out more perfection to the images that we have been taking and processing and sending through all the hidden layers. So this is how complex features are extracted. So if suppose in a feature there are like hundreds of works, so then okay, my bad. So then it will be taking as like it will extract the proper complex features. So coming to skip connections, so skip connections in ResNet allows the network to bypass one or more layers. So skip connections help with gradient flow and elevative the vanishing gradient problem, and skip connection enables the training of very deep network. So skip connection is nothing but in, while you have seen this, right, input node, from input node it will go to hidden layer after processing through convolution and pooling, and again it will go to another convolution process. So here encoding happens and decoding happens. Instead of this, sometimes when the after happening, after we are getting a desired output, if you skip the connections, like skip connection is usually directly it will be sending that, and based on the difference what we get in the output, so we will be considering the which has more value, which has more reward. And coming to residual learning concept, in residual learning, the network learns residual function instead of direct learning the desired underlying mapping. So instead of what desired underlying mapping is, so coming see here it is. So there is an X, there is a node and layer, and which goes through after the weight is added, then activation function is added, and this is on weight layer, and the activation function return, and so will be returned, and the identity mapping is nothing but what we are setting up what we required in the output, and the residual function is difference between the input and the output of a block. See, that's what I told. Like if suppose like you got an output and you want an output, what you want is called desired output, and what you got is the actual output. So based on this difference, that it will be the function is called the difference is brought by residual function. This approach simplifies the learning process and improves performance. So obviously, when you keep on reducing the difference, so you will get the performance will be increased, and the learning process is also simplified. So types of ResNet architecture. So ResNet architecture come in different depths such as ResNet 18, ResNet 50, and ResNet 101, and ResNet 152. So these are some different architectures which is used based on the requirements. And deeper ResNet model tends to have better performance but require more computational resource. So this and all is not a joke. You can't just take a random dual core processor and start installing, and you can't use this. It's a high level architecture that being used for a very there's a difference between deep neural networking and very deep neural networking. So this comes under very deep neural networking. So here the hidden layer is has much more depth than the neural network or the deep learning model. So deeper ResNet models seem to have better performance but require more computational resources. And the choice of ResNet architecture depends on the specific task and data sets. So these ResNets are not only used for images but also can be used for video, audio, text data, any kind of data, and the models for like ResNet 18, 15, and 101 and 152 it is used based on the specific tasks. So coming to training ResNet models, so training ResNet models requires a large data set and significant computational resources. So why large data set, you might ask? So obviously if you want a much good performance, and a large data set is actually compulsorily required. So even though it has very depth hidden layer, so easily it can process that data sets no matter how large it is. And coming to techniques such as data augmentation, batch normalization, and learning rate schedule are commonly used. So these are all the normal techniques which usually used to reduce the difference between the actual output and the desired output. And also batch normalization is basically used to avoid the vanishing gradient problems, and even data augmentation and learning rate also. Learning rate should be set from 0.01 to like 0.25. So this depends on like what task you are performing. And pre-trained recent models are available for training learning on new dataset. So once you have been gone through TensorFlow and other API that provides built-in models, so you will get to know what kind of model you need to learn. And coming to benefits of ResNet architecture have been widely adopted in various computer vision tasks. CV, that is open CV use, no, that is what we use we are seeing here. So ResNet models have achieved state-of-the-art performance on image classification benchmark. So usually like one image has like a billion features in it. So if you give an image like based on what light and color and the size of the image and the shape of the image and multiple things, what kind of objects are inside an image, so this is a much complex task for other kind of neural network. So basically it has achieved the state of art, especially in the image classification. That is because of the very deep neural network which it comes under. And ResNet skip connection and residual concept have influenced the design of other neural network architecture. So this gave a start to other neural network architectures, and that will be discussing in further videos. And coming to applications, image classification. Recent models are widely used for image classification tasks such as identifying objects or seen within the image. They have achieved state of art of the performance on the page. As I said earlier, whatever, that's the application. And object detection. ResNet serves as a backbone architecture for many object detection systems such as your Google Lens, and such as faster RCNN YOLO, and SSD single shot multi-box detector. The deep features learned by ResNet are crucial for accurately localizing and classifying objects with image. So yeah, some of the single shot multi-box detector which comes with a, it's not easy to extract the features from it. So that's one of the challenging thing that can be achieved by ResNet. So transfer learning. So pre-trained ResNet models trained on large-scale data set like ImageNet are commonly used as feature extractors for transfer learning. By fine-tuning these models on smaller domain-specific dataset, one can achieve good performance with limited label data. So basically, you can't be expecting all data will be labeled. So some of them will be unlabeled, and you can't decide. You can't expect that a model will be giving you a perfect output. So without for the unlabeled data, but it will be giving you a much better and output because of the pre-trained recent model. So it will be trained by a large amount of non-labeled data. So coming to conclusion, ResNet architecture has revolutionized deep learning by enabling the training of very deep neural networking. Therefore, it has a much far wide range of features. So compared to regular neural network, and the use of skip connection and residual learning has proven to be effective in improving gradient flow and learning performance. So these are the two main features like skip connection and residual learning. So this you should be remembering in ResNet, and ResNet continues to be a popular choice for various computer vision tasks due to its performance and versatility. So when it comes to image classification, object detection, whatever with an image, first you need to prefer a ResNet network and ResNet neural network, residual neural network basically. So this is it for today. Thank you.